Okay. Screen is visible.
Yes, sir.
So in the last class, we discussed about motion of a link. Okay, and how to find out the velocity on a link at any point. Today we'll start with velocity in slider crank mechanism. Okay, so let me draw one to E. Okay, so slider, just a second. Okay, suppose we have slider crank here having angular velocity, crank is having angular velocity omega. This is point O. This is fixed guide. Point A. OB is the crank having radius R. Okay. Point point A is having a velocity of, let's say, BA. Obviously, it will be in horizontal direction. Okay, and its direction for this particular configuration will be towards right, as you can see, because the crank is rotating in clockwise direction in this particular position, isn't it? And if you consider point B, okay, relative velocity of B with respect to your O will be perpendicular to OB. Okay, so it will be in this way. Let's say it is BB, which is equal to omega dot R. Okay, omega multiply with the link length, that is R. Okay, now we can write here as a slider crank mechanism is slider crank mechanism as shown in the figure where the slider A the slider A is attached to connecting rod, attached to connecting rod AB. uh, let R is the radius of crank OB, and it rotates in clockwise direction about point O with uniform angular velocity, with uniform angular velocity omega. Okay. Now BB is known as BB is known in magnitude and direction, in magnitude and direction, suppose. Okay, and velocity of slider BA may be determined using relative velocity method. Okay. Now, what is the step? uh, First step is from point O, from point O, draw OB, draw OB parallel to VB, such that OB is equal to BB, that is equal to omega dot R. Means magnitude of BB we know it is equal to omega dot R, and we took a particular scale. Accordingly, we draw this OB, which is parallel to the direction of BB, right? So you take a point O, okay. Then from that point you draw BB, okay, BB, capital B, that is O and B, which is parallel to BB. Now second step, since AB is rigid link, since AB is rigid link, therefore therefore velocity of A with respect to B is perpendicular to AB. Okay. So now draw, since AB is a rigid link, therefore velocity of A with respect to B is perpendicular to AB. Okay. So draw a vector, draw a vector, BA, okay, perpendicular to AB, representing VAB, means velocity of point A with respect to point B. This is relative velocity. BB is the absolute velocity at point B. Okay, so we'll draw it now. From point B, we draw a line. Okay, we don't know its magnitude, but its direction is that it is perpendicular to AB. Okay, and its direction will be like this, VAB. Magnitude yet to find. Okay, now mm, third step, from point O, from point O, draw a vector, OA, okay, parallel to the path of motion, path of motion of slider A, which is vector which is vector OA. Okay, so from point O, we'll draw a line which is parallel to VA. Okay, and they will intersect at this point. Okay, so this point will be our A now. Okay, so now I'm erasing and I'm drawing it again. For the reference earlier, I extended them. Now I'm completing. So I think I'm clear. So this represent your VA. Clear?
Yes, sir.
So first step
Yes, sir.
was we choose one reference point O. From that reference point, as we know, the direction and magnitude of the absolute velocity of point B, we draw a line OB perpendicular to BB with some suitable scale. Okay, so we got this point B. Now, from point B, we draw a line which is perpendicular to the connecting rod AB, representing the relative velocity of point A with respect to B. Okay. Representing BAB, then we till don't know its magnitude. Okay, so we cannot locate point A. Now from point A, draw a straight line representing the horizontal slider velocity VA. So obviously it will be a straight line. So both the lines will intersect at point A. Then only you can locate point A. Now, out of this triangle OAB, only we know the magnitude OB. So other two you measure as per your scale. Okay. Suppose you have taken 1 centimeter is equal to 1 meter per second. Okay. And you found your AB is equal to 5 centimeter. That means VAB is 5 meter per second. And suppose you got your OA is equal to 7.5 centimeter. That means VA is 7.5 meter per second. Okay. In this way, you can find out velocities in a slider crank mechanism. Okay. So once you get this VAB, then omega AB. Okay, omega AB you can find out using the relation VAB divided by AB, isn't it? Using this relation we can find, because we know that if we take any link, say AB, and this is the velocity of point B, so this velocity VB is always equal to the angular velocity multiplied with link length. So now we know this, we have to find this. Okay, so omega AB will be equal to VAB by AB. Clear? So
Yes,
in
sir.
this way you can find out
Yes, sir.
velocities and angular velocity. Now we'll take a small example. Okay. Let's say it is given that the crank and connecting rod of a steam engine are 0.5 meter and 2 meter long, 0.5 meter and 2 meter long respectively. The makes the crank makes 180 rpm in clockwise. Here direction in this type of problem is very much important. Okay, so be watchful while reading the question. Here it is given the crank makes 180 rpm in clockwise direction. Okay, when when it has turned 45 degree from the inner dead center IDC, find the followings. First, velocity of piston, velocity of piston, bit B, angular velocity of connecting rod, bit C, velocity of point E, okay, any arbitrary point, velocity of point E on connecting rod 1.5 meter, okay, from the gudgeon pin. Location of point E is given to you. Now the schematic will be like this. Let's say uh, this is your slider. Okay. Draw the center line. Then this is our connecting rod. This will be your crank. Okay. Now give one imaginary circle to indicate the coverage of the crank. Now let's say this point is A, this point is B, this is O, and this is our inner dead center. This is our outer dead center, 180 apart. Okay, position of crank is given 45 degree. Na kete thila 45 degree, 45 degree, and it is moving in clockwise direction. Clear? And position of point E is given here, somewhere here. It is 1.5 meter.
Yes, sir.
So it is given that rotation speed of crank is given. Okay, so you can say NBO is given to us 180 RPM. So our omega BO will be equal to 180 into 2 pi by 60. Okay, so it is 18.85 radian per second. Now length of OB is given, that is 0.5 meter, and length of AB, the connecting rod, is given 2 meter. Length of AE, as I told, is given 1.5 meter. Now the linear velocity of point B with respect to point O, that is VBO, is equal to omega BO into, here it will be OB. Remember the notation I have already told you. So which implies your VBO is equal to 18.85 multiply the distance, that is the length, So it will be 9.426. You please recheck, huh? I may be wrong. So it is 9.426 meter per second. Now we have to find out velocity of piston. Okay, how to find the velocity of piston? Yes, someone has turned on the audio. Please switch it up. Now to find out the velocity of piston, so first step is draw a vector. Draw a vector OB. Okay, perpendicular to AB to some suitable scale, okay, representing BBO. Okay, so we'll take a reference point, okay, and from that reference point we draw a line, okay, we draw a line which is perpendicular to the crank, okay, crank OB. So it will represent the relative velocity of point B with respect to O with some suitable scale. Okay, so you'll get this line OB. Now this vector OB is our BBO, which is equal to 9.426 meter per second. Okay. Now second step, from point B, okay, draw a vector BP, okay, which is perpendicular to your BP. Okay, sorry, I have not shown here the point P. Okay, this A is the slider and P is the point. Both are at the same instant, so we are writing here as P also. Okay, for this reason I am given. Okay, so P and A are same. So BP represents the velocity of P with respect to. So from point B, draw a vector BP perpendicular to the connecting rod BP, representing, can write, representing velocity of point P with respect to B. Okay, so it will be B P B. Okay, and so we'll drop a line here in this way. Okay, so it will be this direction. Okay, so this is point P, um, and and from point O draw line OP. Okay, this is small. Okay, OP representing the velocity of point P, or you can say velocity of point A. Both are same. You can use either notation. Okay, no issue. Which is the linear velocity of the slider, velocity of slider. Okay, so I'll draw a horizontal straight line. So the both will intersect at this point P. So I'll get my P point now. So this is your velocity of point P, or you can say point A, and from B to P will be the relative velocity of point P with respect to A. Sorry, B. Yeah. Now, third step, angular velocity of connecting rod. Okay, angular velocity of this connecting rod. We have this B. Okay, this we can easily find out from this diagram, scale diagram. So this BPB is also equal to your no, this is equal to your vector BP. Okay, from this vector. So you measure it, you will find it is coming approximately 6.8 meter per second. Okay, from the diagram you can find out BPB. So once you get this BPB, or omega PB, that is the angular velocity of the connecting rod, obviously, will be BPB divided by PB. So 6.8 divided by 2. So it is 3.4 radian per second. Okay, it is omega PB. Now, fourth one, your velocity of point E on connecting rod, now let's say it is VE, okay, which is equal to so which is equal to OE. How, which one is OE? Let me show you. So on this line BP, you take any point E such that it is as same as with the scale with respect to your original diagram. Means this P point is our A point, all of you know. So from capital A to capital E, what is the distance in actual case?
1.5.
1.5 meter. In actual case, this is 1.5 meter, and this one is zero point 0.5 meter. So if you have chosen a scale accordingly, so suppose it from P to E will be 1.5 centimeter, from E to B will be 0.5 centimeter. Let's say I'm telling. Okay, so you can easily locate this point E. Now you join O to E. Okay, so let me redraw it again. Let's say this is E. So this line will give you velocity of point E. If you measure it, you'll get the value as per the scale. Now, with respect to my scale, it is coming around 8.5 meter per second. So you please check. Okay, all the values will be same. Okay, 1 to 2% deviation is allowed in this case. Okay, so nothing to worry. So in this way you will solve any problem related to velocities in slider crank mechanism. Am I clear to all of you?
Yes,
Yes,
sir.
sir. Yes, sir.
Hmm. So in this case the first step is you choose any reference point O. From that point O, you draw the line representing the point B on the crank, okay, which is perpendicular to the crank. Okay, so you will get the point B. Then from point B you draw uh, a line which is perpendicular to the connecting rod, representing the relative velocity of point A, or you can say point P, on the connecting rod. Then from point O you draw a horizontal line representing the slider velocity, which is our VA. So both points will meet at, suppose, point P. Now you measure this, you will find out the velocity of connecting rod, and if you measure this, you will find out the velocity of slider. And at any as per your scale, you choose point E. Okay, then you join here, you will find the velocity of point, any arbitrary point E here. Okay, so this is the step. Now another important aspect is mm, rubbing velocity. Rubbing velocity at a pin joint. Rubbing velocity at a pin joint. It is very important. You used to get short notes on this. Okay, so let's say we have two links here. This is one link, this is one joint, and connected with a second link. Okay, let's say this is point A, this is point B, and this is the joint O. Now link OA has, suppose, angular velocity omega 1 in clockwise direction. Link OB has angular velocity, let's say, omega 2 in anti-clockwise direction, suppose. So we can write that in a pin joint, of a mechanism, rubbing velocity okay, is defined as is defined as the algebraic sum of angular velocities of two links connected by pin joints okay, multiplied by the radius of the pin. Remember this. Okay, now as I told you, consider two links here. So considering two links OA and OB connected by a pin joint O. Okay, let this omega 1 is the angular velocity of link A, and omega 2 is the angular velocity of link OB, and R is the radius of pin. R is the radius of pin. Suppose this is the pin, okay, and this one is the radius R to which both the links are connected. So this is your R. Now what will be the rubbing velocity? So rubbing velocity at pin joint O is omega 1 minus omega 2 into R if if links uh, move in same direction. Remember that if both the links are rotating in the same direction, it will be omega 1 minus omega 2, and it will be equal to omega 1 plus omega 2 r if the links move in opposite direction. Okay, now this is important. So if the pin joint connects,
Sir,
yes,
ସେ radius part ଟା ଟିକେ କହିଦିଅନ୍ତୁ sir ଟିକେ କୋଉଟା radius
ଆମର
କହିଲେ?
radius ମାନେ suppose ଏଇଟା this is one link, okay, and this is the joint where both the links will be connected. So the joint at the joint point, suppose O, and the radius of this pin is your R. ବୁଝିପାରିଲ?
Yes sir, sir I'm ବୁଝିଲି.
So this is radius. So you can write if the pin joint connects one sliding member and one turning member, then angular velocity of sliding member is 0. Okay. If the pin joint connect to one sliding member and one another turning member, then the angular velocity of the sliding member will obviously 0 because there is no angular moment here. So then your rubbing velocity at pin joint will be only omega dot r, omega of the turning pair and the radius of the pin joint. Okay. So omega is the angular velocity of a turning member, and r is the radius of pin. Okay, so you remember this. Suppose a short question of 2 mark will be given to you, representing one link as the sliding pair member and another as your turning member. And suppose one surplus data will be given to you, omega 2. So, but that should be 0, remember, if it at all it is a sliding member. Okay. Now, we'll solve another example. Mm, okay. Now, suppose it is given in a 4 bar chain, in a 4 bar chain ABCD, ABCD, it is given that AD is fixed, okay. AD is fixed and is 150 mm long, 150 mm long. The crank, the crank AB, the crank AB is 40 mm long. AB is 40 mm long and rotates at 120 rpm clockwise, while the link CD is equal to 80 mm, oscillates about D, about point D. Okay, full stop. Your BC and BC and AD are of equal length. So find the angular velocity. Find the angular velocity of link CD when when angle when angle your BAD is 60 degree. That means um, the arrangement is like this. Let's say change the color. Mm, this is the fixed link, one link. This is another link, yeah, and this is another. So A, B, C, D, and this angle is 60 degree, and AB is given. AB kete कहली? AB is 40 mm. Okay, then BC, CD is given 80 mm, 80 mm, and BC and AD are of equal length. Okay, equal length, and the velocity of point B will be perpendicular to AB, obviously, and this length is given 150 mm. 150 mm. AD is, okay, because AD is given 150. Now, what to find? Find the angular velocity of link CD. Okay, angular velocity of link CD means omega CD ଆମର ବାହାର କରିବାର ଅଛି. We need to find out omega CD. So, first step is to note down the given data. Always given data. कौन ଅଛି? Now here we have NBA. NBA is given 120 RPM, and so our omega BA will be 120 into 2 pi by 60. So 4 pi, that means it will be 12.56 radian per second. Now AB is 40 mm, okay, or you can say 0.04 meter, and BA will be equal to omega BA dot AB, isn't it? So omega BA is 12.56 radian per second. AB is 40, that is 0.04 meter. So it is 0.503 meter per second. Okay. So we got BBA. Now we'll draw the velocity diagram. So in velocity diagram, the first step, since you can write, since link your AD is fixed, take point, mm, take a point, let's say AD, okay, AD to represent both point A and D. Okay, to represent both point A and D. Okay. So we'll take a point here. Remember this. If a link we are considering which is fixed, then that link will represent by 2 points. Okay. Let's say this is the point A, comma D. Now second step is from point AD, from point AD, draw a vector AB, draw a vector, sorry, small, it will be small AB, representing velocity of point B with respect to A, so which should be perpendicular to AB, okay, with some scale, so we'll draw that BBA, okay, so this is BBA perpendicular to AB, direction is perpendicular to AB. Now we'll get our point B, okay, because its magnitude is also known to us, so it is our point B. Third point is from point B, draw a line, perpendicular to BC, representing velocity of point C with respect to B. Okay, so from point A, we'll draw a line BCB. Okay, perpendicular to BC. So we'll draw a line. We don't know the magnitude. So it will be obviously B capital C B, because it is moving towards C, so that's why C comes first. Okay, remember this. Now from point A, again from point, you can say D. Okay, from point, because they are same. From point D, draw a line perpendicular to CD. Okay, representing representing BCD BCD, both both the lines both the lines will meet at point C. Both the line will meet at point C. So we'll draw BCD from here, from point D. Okay, so this is my BCD, which is perpendicular to CD, and both these lines will meet here. Okay, at point C. So I'll erase these extra portions and I'll draw it again. Okay, so it will be like this. Okay, now by measurement, your BCD is equal to 0.385 meter per second, and CD we know it is 80 mm, which is 0.08 meter. Now VCD, okay, will be equal to your omega CD dot CD. So your omega CD will be equal to BCD divided by CD. So it is 0.385 divided by 0.08. So it will be 4.8 radian per second. Okay. This is the omega CD, that is angular velocity of link CD. Okay, and it will be, orientation will be, it will be clockwise. So you should write here clockwise about point D. Okay, because as per this particular configuration, because AB is moving in clockwise direction, so it will also be clockwise. So this is all about your uh, velocities, okay, in mechanism. Now next will be your acceleration in mechanism. Okay, acceleration in mechanism. So shall we take a break of 2 minutes? Then we'll start.
Yes, sir.
Okay.
Yes, sir.